Now, this room that you see here behind me wasn't even in existence in 1965. It came to NASA much later in its program. In fact, the first mission control room that was ever, well, active here in this facility was actually located on the north side of this building and was first brought online in April of 1965. And it's known as MOCR 2, or Mission Operations Control Room 2. And the first mission MOCR 2 ever controlled was a mission known as Gemini 4. And in April of 1965, on that mission, a man named Ed White performed the first American EVA, or extravehicular activity. Essentially, he performed the first American spacewalk. And that would just be merely the start of the many historic missions that room would go on to see. We would go on to see 9 of the Gemini missions, all of the manned Apollo missions, and 21 of the first space shuttle missions ever flown. Now, in 1995, NASA decided that the constant updating and upkeep of MOCR 2 was too costly. So MOCR 2 was shut down and brought back the way it looked during the 60s. And this room that you see here behind me was officially brought online. Now, this room is known as the White Flight Control Room, or the White Ficker. It is 100% the real thing. All right, I lied just a little bit, folks. It's 99% the real thing. The plants along the window here, they're fake, but everything else you see in front of you is real. Now, this room has seen its own fair share of history. This room has been shuttle mission control ever since 1965, so it's seen the very height of the shuttle program. The beginning of the construction of the International Space Station, which is was the world's largest peacetime collaborative effort ever undertaken. So the completion of that monumentous construction effort, and finally the end of the shuttle program earlier this year. Now, ladies and gentlemen, please know that all because the shuttle program has ended here at NASA does not mean we're closing down our doors and everybody's going home. The end of the shuttle program merely brought about the end of a chapter in our history here at NASA, and now allows us to embark on a new chapter of exploration. And this chapter is going to be the Orion capsule, which promises to be the most advanced space vehicle mankind has ever developed. It'll be able to take astronauts back to the International Space Station, yes, but it'll be able to take astronauts to deep space. Basically take us back to the moon, take us to asteroids, so we can see basically the very beginnings of the universe. And finally, it'll allow us to set foot on the planet Mars. So that way we can explore that planet for the betterment of all mankind. Now, in the meantime, ladies and gentlemen, we are keeping rather busy, because the first test launch for the Orion capsule is not until 2013, and the first test mission, all fingers crossed, the first manned mission, is not until 2016 for the Orion capsule. So in the meantime, the astronauts, the scientists, and engineers that work here on JSC property are developing the tools and the training that our astronauts will need to use to be able to work the Orion capsule and survive in that capsule. And we're also still controlling the International Space Station, which is going to be the main space, the space of NASA for the next couple of years. Now, the ISS mission controller you can see on this TV screen here, but it's actually located just out this door over here and over a couple of hallways. Flight Control Room 1, or Ficker 1 as it's known, is manned 24 hours a day, 7 days a week, 365 days a year, because we always have someone on board the ISS. And currently on board that orbiting laboratory, we have 3 people. 2 Russian cosmonauts and an American astronaut are currently on board the International Space Station, working diligently with the experiments on board. Now, speaking of that orbiting laboratory, you can either take a look at this TV screen here, or at the center screen here you see the mission control room. And what you're looking at now, ladies and gentlemen, is called an orbital tracking map. It's currently tracking the live location of the ISS above our planet. Now, as you can see by looking for the white icon that's surrounded by the white circle, it's currently off the very southern tip of South America. That's where the ISS currently is. Now, you're going to see this icon flicker in order to indicate its movement. Well, it's actually very deceptive. The ISS is currently traveling above our heads at a speed roughly 17,500 miles per hour. That's roughly 5 miles per second. With that perspective, ladies and gentlemen, if you were to take off from here and travel at that speed, you'd be able to get to Europe in about 45 minutes. And it's actually what private space industry is looking at taking advantage of. So in the next 40 to maybe 35 years, you could be looking at weekend trips to Paris. All you have to do is hop on board what is essentially an airplane shuttle, go up into low Earth orbit, and then come back down at a predetermined location. So, you never know. Keep an eye out for that, folks. Now, when you're going at that speed, ladies and gentlemen, the crew on board the International Space Station, well, they see a total of 16 sunrises and 16 sunsets in one day. They cross over the international date line 16 times, so you could say the crew, they get a bit of a jump on the work week. And they orbit the globe once every every 90 minutes. Now folks, if all this combined does not actually serve to mess with your internal clock, I honestly don't know what will. So everything we do in space is kept on one time, and that time is Greenwich Mean Time or Zulu time. Prime meridian, which runs through England, well, that is the basis for our clock in space. Doesn't matter where the space vehicle come from or what mission that kind of happens to hail from. Everything in space is kept on Greenwich Mean Time. Now, your average day on board the space station will look just a little something like this. First off, you gotta wake up and exercise 2 hours every day in order to stave off the loss of bone and muscle mass. You also have to maintain the systems of the International Space Station. Those are your housekeeping chores. It's just something you gotta do every day. And finally, you have to work with the over 1,000 experiments that are currently on board that orbiting laboratory. Now, these experiments run the gambit from studying on human physiology, physics, chemistry, and even agriculture. If you think of an experiment, there's probably an experiment, or you think of a science, I should say. There's probably an experiment for it on board the ISS right now. Now, weekends on board the space station are kind of considered your days off. It would be rather unfair of us to send you up there for about 6 months, which is how long your average day on board the space station is, and tell you work 7 days a week. After all, when you're an astronaut for NASA, you are technically a government employee. You get weekends off. And what the astronauts like to do with their spare time on board the station? Well, they like to read books and surf the web, update their iTunes, phone home and watch TV and watch movies, so they get satellite in space, guys, not cable. And they also like to look out the window. I know that sounds rather mundane and low tech, but if you'll bear with me just a tiny bit of channel surfing. What you can see here now, ladies and gentlemen, is a live feed from the International Space Station. If I do say so myself, they get one of the best views in the world. Now folks, at this time, I do hate to say it, but I do actually have to send you underway pretty soon. I have a bit of a schedule I have to keep you on. You actually have more stuff you have to make on phase 4. Before I send you off, I'm going to go ahead and open the floor up to any questions you might have about what's going on now here at NASA, what's going on in space, anything. Just raise your hand, overcome your fears, and I will answer those questions to the best of my ability. Or you can ask why I can't work with the remote very well, whichever one. If I have any questions, though.
Are each of the lines on the map tracking, or what are they tracking?
Okay. Let me use this so that way I'm not doing this. Okay. Basically what we have here, so the white lines that you see going across the screen, that's the middle line's the present projection of the International Space Station. The line above that one is its past, and the one below it is its future projection. So that's basically the path of the International Space Station in 3 different times. Then the big yellow, green, and blue circles, those are actually our satellite communication network ranges. Now sometimes we do go through an area of bad reception, and that just means we've lost contact with the ISS for about 5-6 minutes. That's when you'll see everyone in the ISS mission control room get up and get a coffee break. And then come back once everything's all good again. It's just like, going through an area of bad cell phone reception. You get that in space too. And the little yellow circles that you see kind of going over what was the former Soviet Union, that's actually the Russian air-to-ground communication satellite network. So that's what those yellow circles are. And that's essentially what the lines on the orbital tracking map is. Now you will see those kind of big white circles. That's the South American anomaly. I'm not quite entirely sure what that is, and if I could explain it to you scientifically, I just know that's what that particular white circle is. That's off the coast of South America. So that's basically what you're looking at when you see the map. And the little orange dot is the sun. It says sun underneath it. Do you have any other questions?
So when does this room become live?
Well, this room, since it was a shuttle mission control room, it's not actually being used to actively control any missions. What it is being used for, it's being used to help basically as a backup room for the International Space Station mission control room. And it's also being used as basically a training and certification room. So that way we can train and certify new flight controllers to work on the main floor of the International Space Station mission control room. Now, there's a bit of a debate whether or not the Orion project will be controlled out of this room, or if we're going to allow private space industry to use this room. It depends on who, I guess you could say, who basically wins the argument. But in the meantime, that's what this room is being used for, and to be honest with you, I'm hedging my bets on this room also being used as the Orion mission control room as well. But that's not going to be for a few years. But with everything that's taken place out in this room, I wouldn't see why they wouldn't use it. Okay, I've got time for one more question. before I send you off, I want to leave you with this thought. You're currently in the building where mankind's journey to other worlds actually began. And earlier in my speech, I mentioned a room known as Mocha 2. And from that room on July 20th, 1969, we heard the first words ever spoken from another celestial body. And those words were, Houston, Tranquility Base here. The Eagle has landed. The first word we have ever heard from another celestial body was the word Houston. And this, ladies and gentlemen, is Houston. This is home. This is where you call when you're in space. Now, folks, at this time, like I said, I do have to go ahead and send you on your way. I am going to ask you, please try and remember to return to your same rows on the tram. That way, everyone is guaranteed a seat back. And if at this time you please go ahead and follow your host and your driver back down the stairs. I'd like to thank you very much for your time and attention. Folks, please enjoy the rest.